And good morning. How's everybody doing today? Dr. Chris Roddenberry coming to you from the great metropolis of Willow Springs, North Carolina on a on a beautiful Thursday morning. Sorry, that was my phone. I've got it sitting up here so I can watch the chat. How's everybody doing today? If you are here, go ahead and type in the chat bar and let me know you're here. Looks like we have a couple of people here maybe. Fantastic. There we go. Hi, welcome to class. Thanks for coming today. Today is Thursday. It is the first week of Module 4. So remember we had our webinar last night, which was well attended. And today your goal is to complete the discussion board by 11:59 p.m. tonight. In order to complete it for the first week, remember you have to type in your original response. And then next week, I'm going to want you to respond to at least 2 different people to get full credit for the discussion board. Looks like we've got a couple of people here. Good morning. How are you doing? Good to see you. All right, let's go ahead and get into the second part of Chapter 8 today. We're not going to spend too long on today. We had a long day yesterday. Hopefully we won't take as long in class today. I'm going to talk a little bit about memory. We're going to talk about memory in action. So yesterday I presented to you the cognitive perspective. I suggested to you that the invention of the computer caused psychologists to really believe in the idea of humans as information processors. And cognitive psychologists set out looking to understand, I guess, what we would call the programming instructions of the human being. Which processes did the human as it processed information? And then yesterday I gave you this pretty theoretical model of how the mind might work with an attention part of our mind, with an active rehearsal part of our mind, and with a long-term storage part of our mind. We talked about the Atkinson and Shiffrin 3-box model of memory, with the sensory memory, the short-term memory, and the long-term memory. And I want you to understand that as an organizing principle of the brain. So really what I want you to take away from this class, okay, is the idea of the information process being based on the analogy of the computer. How are humans similar? How are they different from computers? And also this idea of human beings as engaging in 3 sort of processes: selective attention, rehearsal, and storage. So I do want you to sort of have this abstract idea of how the brain might work. I then introduced the idea of schemas and the idea that information is stored in your mind in these nodes of conceptually related information. So I think I used the term circus. I mentioned circus yesterday and asked, I think it was Lena, to tell me what things came to mind. And she said acrobat, juggler, clowns. And so she said the typical things that you and I would associate with a circus. And I try to suggest to you that your mind is composed of these schemas, all interconnected. And the reason I suggested that to you is because one of the hints that I gave you yesterday about getting information into your long-term memory was that you needed to relate the information you were trying to learn to things that were already locked in your memory in these schemas. We're going to go back and talk about memory in action today, and we're going to talk about why different memory strategies work better than others. And then I'm going to talk about the nature of memory. Okay? Now, types of memory stores. One of the questions you might ask is, are all memories created equally? Are all memories stored in the same place? Or are there different types of memories, and are these different types of memory systems controlled by different parts of the brain? And so in a sense, we're talking about the modularity of memory. Remember that term from chapter 2, modularity? And I suggested to you that all of our abilities were controlled by different parts of our brain. You can think of our brain as a bunch of different computers engaged in a bunch of different activities. Well, you can take the whole concept of memory and you can ask how modular is memory. All right. And so one of the ways in which we've learned about this modular nature of memory is through case studies of people with brain damage. Okay, so if you remember back in chapter 1, we talked about case studies as a research methodology, and I talked to you about lesioning studies as being important in chapter 2 for understanding the nature of the modular mind. Same thing with memory. People with different areas of the brain damage show different types of memory deficits. And one of the first ones psychologists learned about was really the difference between the process of storing a memory and the location of where that memory is stored. So I'd like to introduce the idea of retrograde and anterograde amnesia. So sometimes when people suffer brain damage, they are unable to remember things that happened before the accident, okay? But these people can go starting from right there, and they may not, they'll remember some things from before the accident, but there may be some memories that they can't access. But this is for memories that happened before the accident. We call this retrograde amnesia. On the other hand, but these people can form new memories. You can tell them new things, they can have new experiences and remember those. All right. Now, on the other hand, there are some people who have what's called anterograde amnesia, and because of these people's lesion in their part of their brain, they can remember things that happened before the accident, but they can't form any new memories. All right. And so what the difference between anterograde and retrograde amnesia tells you is that there's obviously one part of your brain that is responsible for storing new memories. And then there's another part of your brain that holds these memories. So in the case of people with retrograde amnesia and they can't remember anything before the accident, what happened is they damaged the part of the brain where the memory is finally stored. And people with anterograde amnesia, the place where information is stored isn't disrupted, but the part of the brain that writes material onto that part of the brain is damaged. So we learned about this idea of the process of storing versus the location of storing. And probably the most famous case study is a fellow named H.M. He's now, that was his initials. Typically in research studies, they would identify you by your initials. And Henry Molaison demonstrated the function of the hippocampus as the brain structure responsible for storing the memories. So your hippocampus is responsible for writing memories into your brain. We'll call this process of getting a memory into your temporal lobe, into your memory system so you can hold it, we'll call that consolidation. Every time you bring a memory up into your conscious awareness and are focusing on that information, you have a chance to consolidate it on your temporal lobe. And the part of your brain that does that would be your hippocampus. Now, your hippocampus is part of this thing called your medial temporal memory system, which is beyond the scope of an introductory class, but involves your amygdala, your hippocampus, and this part of your inside your temporal lobe called your entorhinal cortex, which are several structures that you don't need to know for this class. But what I do want you to know is the value of the hippocampus. It decides what's going to be stored in your memory. Okay. Now it's also responsible for automatically storing your location, because knowing where you are is one of the most important survival tools that you might have, a sense of direction. So your hippocampus stores your location, and it's also responsible. Other memories that need to get to your temporal lobe have to go through your hippocampus. Remember, your hippocampus is also attached to your amygdala, and that allows you to know when things are important enough for your hippocampus to remember them. So these structures are all working together to decide and help to decide what is important to store in your memory and to what to store in your memory. So we learned from Henry Molaison that your hippocampus is very responsible for storing new memories. Does that make sense? I hope that makes sense. Now, let's talk about some other structures here. So if you look down here in this picture right below me, you'll see the purple hippocampus that circles. It's actually a little horseshoe shaped thing that's sort of facing the front of your body. And on the front part of each horseshoe are these two structures called your amygdala. And your amygdala is your emotional center. So you see that structure right there is for the emotions and storage of memories. Now, one of the things that we also learned about amnesia and memories is that there is a difference between what we would call explicit memories and implicit memories. If you think about it, knowing how to put on your pants is a memory. You have to remember what to do next. Left leg in, right leg in, pull pants up, button pants, then zip pants. That's several steps you have to remember. Riding a bike is a memory of how to move your arms and legs. Those are memories just like your knowledge of who George Washington was. The only difference is you can ride a bike without thinking about it, but you can't remember George Washington unless you intentionally try to. So we're going to differentiate between two types of memories. Memories we'll call explicit memories and memories that are implicit memories. An explicit memory is anything that you have to bring into your short-term memory, into your consciousness in order to remember. So the sum of 5 plus 4, which is 9, you have to think about 9 consciously for that to be there. The same thing for George Washington. The same thing for who you're supposed to meet for dinner tonight. Those are conscious, explicit memories. And there are many different types. So we can think of some as being semantic facts, who George Washington is. Okay, that's a conscious, explicit memory, but it's a memory for an abstract fact. Okay, and then we can differentiate that from the knowledge of where I was last night. Okay, right? So in a sense, that's an episodic memory. Last night I was sitting in this chair right here teaching a psychology lesson. Okay, we'll call that an episodic memory. And then you can ask me where I was born, and I can say, oh, I was born in Mobile, Alabama. That's a bit of self-knowledge. But if you think about it, knowing who George Washington is, knowing what I did last night, and knowing where I'm from are explicit forms of memories. We have to bring them into our awareness. On the other hand, how many times do you dial a phone without even thinking about it? Knowing how to dial a phone is a memory. Riding a bike is a memory. Knowing how to drive a car and how to use the blinker and where you're going, that's a memory. But a lot of times we can drive, ride a bike, play a guitar, or do anything else without really thinking about it. You've probably heard the term muscle memory. Muscle memory. When people are referring to this thing called muscle memory, what they're talking about are implicit memories. Okay? So now that you know the difference between those two types of memories, and I will ask you to know the difference between those two types of memories on the test, what you're going to find is that explicit memories, you're going to find more in your temporal lobe and your prefrontal cortex. Okay? So knowing information about yourself is going to be in your frontal lobe, and your temporal lobe is going to be your memory for the events that happened to you, for who George Washington is. These things are going to be stored more in your frontal and temporal lobes. Okay, and if you look at the picture right down here, it's got your prefrontal cortex. Your ability to pay attention is also controlled in this frontal part of the brain. People with ADD who have attention-related problems, they take Adderall, and Adderall activates their frontal lobe and helps it take over their attention process. So being aware of things and having your short-term memory, your conscious awareness, and your explicit awareness is going to be more of your frontal lobe and your temporal lobe. Okay. Now here's the deal. As I suggested to you, memory consolidation is controlled by this hippocampus thing. All right. Now, in terms of implicit memory, so we have two kinds of sort of implicit memories. Now, as I suggested to you, muscle memory or procedural memories are controlled by your cerebellum. Damage to your cerebellum is going to disrupt your ability to do things like walk and ride a bike. And what you're going to see is that you don't remember how to move your body parts in a coordinated manner. That's what walking is. It's remembering which leg is going forward at one time and how the knee is moving and the ankle is moving. These are all memories, if you will. And these are procedural memories are controlled by your cerebellum. Damage to your cerebellum is going to make you, you're going to be one of those people that walks funny or moves funny after the accident because you'll have lost this, this ability for this procedural memory. On the other hand, knowing what you're afraid of or what you like is also a memory. A learned emotional experience is a memory, if you will, okay? And what they found experimentally with monkeys and in case studies with human beings is that when you damage someone's amygdala, they lose their ability to fear objects. They don't remember those innate biological fears that they are supposed to have. So monkeys, in experimental studies with monkeys, they found that the monkeys lose their ability to fear their predators. They begin to eat their feces and they start to copulate with inanimate objects. They forget those kinds of things that disgust, scare them, and make them aroused. They sort of lose their emotional memories. Okay, so that's what I want you to know from this particular lecture is that one of the things we've learned is that depending on which part of the brain you damage, a person is going to lose specific types of memory abilities. Now, I don't know if any of you folks have ever heard of Alzheimer's disease. Alzheimer's is a memory loss disease that occurs because neurons in your brain begin dying off due to plaques and tangles that grow in your brain. And as people's brain areas die, they will begin to lose memory abilities associated with those. And if you've ever met somebody or talked to somebody who's gone through it with a parent, they'll often talk about watching somebody being slowly erased because you lose these memories gradually and over time. Now, the disorder works from front to back. So what typically tends to happen is people lose their explicit memories first and their personality is affected. So people who have Alzheimer's, first their personality and their self-knowledge will be damaged, and then they'll start remembering their friends' names, and they'll start forgetting important dates and where they are. And then as they this moves farther back and starts to attack the cerebellum, they'll lose their memory for how to do simple tasks like maybe walk or talk or use the telephone. So I like to think of the progression of this disease as forgetting that you were supposed to call your Aunt May, then forgetting your Aunt May's, first it's forgetting your Aunt May's name, then forgetting that you have to call your Aunt May, then forgetting where the telephone is, and then forgetting how to use a telephone. So these memories, as this cell death progresses towards the back of the brain, the person goes from losing explicit memories to losing implicit memories. So what I want you to understand from this slide, from the last couple slides, is this idea that memory is modular, and that there are different parts of the brain which control the different types of memory stores and memory activities that we engage in. Frontal lobe, short-term memory. Temporal lobe, explicit memories. Hippocampus, memory consolidation. Amygdala, emotional memories. Cerebellum, your procedural memories. So I basically want you to know these sorts of things. And I especially focused on the role of the hippocampus in the memory process. So I want you to understand that there are these different parts of the brain that relate to our memory. Now, here's the thing. If you want to improve your memory, one of the things you need to do is to sort of use the idea of these different brain areas to help use their strengths to help you store and remember important memories that you might want to. Your hippocampus is very important. This visual occipital lobe, which does such a great job of creating images, and your visual association areas that are located in your temporal lobe and near your temporal lobe. So what you're going to want to do is you're going to want to use your sense of vision and your sense of location in order to remember things. Memory athletes, those people with super developed memories, know how to use these two structures. As I said before on Tuesday, as I said last night, memory is not something you are born with. It is an ability and a learned skill that you develop. If you have poor memory, if you tell me right now, Chris, I can't remember anything, and that's why I do poorly on my exams, it is not because you have a bad memory, it's because you have an untrained memory. Meta memory is the understanding of how memory works. Unfortunately, most schools, no educational system teaches meta memory, which they should teach first. Meta memory are the strategies that help you to use your memory properly. And so meta memory relies on an understanding of brain anatomy. Your brain has a huge visual center that is great at creating these amazingly vivid images in your brain. And it's close to and connected to your temporal lobe, which is your memory center. And you also have a hippocampus, which is very important and automatically programs where you are in space and uses that as a memory tag cue. And you also have an amygdala, which lights up whenever you find something funny or scary or disgusting. And so and when you're creating a memory, what you want to do is create memory traces, just like that schema. I said that schema. Emotional associations are links, location associations work as links, and pictures in your mind work as links. And so what you need to do in order to really remember things is to get in the habit of thinking about associations that are colorful, funny, and include locations of places. So last night in class, I don't know if either one of you here, Janiyah, I think you may have been in class last night. I was talking about learning some Spanish vocabulary, and I mentioned the word for vulture in Spanish. I like how you connected your Spanish words, right? And you know what? I may pronounce it wrong, but I know that it's buitre or buitre is a vulture. Buitre, because I imagine a boy holding a tray, a boy waiter, and he was at my favorite restaurant, which is a location, buitre. And so from now on, whenever I try to think of that word, it is stuck in my mind. I guarantee you, 10 years from now, I will not have forgotten buitre, el buitre. And I apologize for those of you if I'm pronouncing it wrong and we have anybody Spanish on the broadcast. Laugh at me and correct my Spanish. I will go look it up, buitre. And so boy holding a tray. And so that was a funny image in a location for me. Janiyah, and I did that so easily. And after that class, I went back a half an hour later and I tried to call up the word for vulture and it just popped right into my head. And it's kind of cool how you can, if you get in the habit of doing that, the thing that people are thrown by is it's not a natural habit at first. And so it seems like something extra to do, Janiyah. But if you practice it half a dozen times, it'll start to come naturally and you won't have to expend any energy on it. And then it will just do nothing but be a help to you. So when I learned sea snails the other day, I remembered that my friend Kara likes to drink cola. So los caracoles is sea snails. And so I just think of my friend Kara sipping a teeny tiny bottle of Coke, not a can and not one of those plastic things, but a very nice looking bottle of Coke, caracoles. And so I'm able to stick words in my memory because I understand the parts of my memory and how they can all contribute to a very strong memory trace. Hope that makes sense. Now, having said all of that, Janiyah, I am going to tell you that your memory is one of the most unreliable things that you have. And furthermore, I'm going to tell you that it was designed to be unreliable, to change a little bit. When we create memory traces, especially memory traces for episodic memories, things that happen to us, these memory traces are not perfect. They change every time we go in and access our memory. So, one of the ways in which computers and humans are different is that when you save your Microsoft Word document, when you save your English paper as a Microsoft Word document, that document does not change. Not one single word is changed in that paper that you wrote. On the other hand, if you save, when you save something into your mind, it's the same thing as having the next time you open that document, imagine if you had changed the vocabulary based upon the words that you were currently thinking of. And the words in your document would change every time you opened your document. That's actually how a memory is. So computers and humans are different. Computers save exact replicas of what you want them to save. Human beings save the kernel of the memory and then add details to it. And a lot of times it uses the schema that you have to add the details. So if you ask me about my 9th birthday party, I will tell you absolutely yes, I had a 9th birthday party. You know why? Because I can remember that one person in particular was there, Stacy McCarver. I was so in love with that knob-kneed, skinny-looking girl when I was 9 years old, and I made sure that I invited her to my birthday party and that she came. And the only thing I really can tell you with certainty that I remember is that that cute little brown-haired girl was there. Now, did I have a birthday cake? I'm going to say yes, but you know what? Birthday cakes usually go with birthday parties. Did we play games? Well, birthday games usually go with birthday parties, so I would assume yes. Did I get a lot of presents? Well, I think I'm a nice guy, and I know people typically get birthday presents at birthday parties, so yes, I got presents. So here's the deal. You asked me about my memory of my 4th grade birthday party when I was 9, and I will tell you that Stacy McCarver was definitely there. And we had presents, and we had cake, and we had played games, and it was a sunny day. But you know what? All of those details may or may not change every time I access that memory. Now, why would humans have a memory like this? Isn't this a problem? No, this is actually an advantage of memory. Memory was not developed, memory did not evolve in human beings to tell us about the past. No animal needs to know how wonderful last night's dinner was or where it was one birthday ago. Memory is not for the past. Instead, memory helps us predict what will happen in the future. So last time I was near that saber-toothed tiger, it almost ate me. And so I know that my life will be better off if I am not close to saber-toothed tigers. On the other hand, I remember we walked 1 mile to the west yesterday and we found a big river of water where we could drink all the water we wanted, and there were some fruit trees that we ate and filled us up. And so I want to remember tomorrow where to go to get that good thing. So memory, in a sense, is designed for the future and not the past. Okay, Brenda, so you remember that too. All right. And so I hope you'll remember forever that a vulture is a boy holding a tray, a buitre, right? El buitre. So now we know that. And sea snails is my friend Kara drinking colas, caracolas. All right, so you'll remember that. Now, here's the thing. If you don't do what I'm doing, if you don't intentionally try to save your memory as perfect, what's going to happen is your memory is going to save the kernel. And depending upon what happens when you're asked about it, when you bring that stuff from your long-term memory back into your short-term memory to rehearse it, you're going to rehearse it using different concepts, and you're going to change that memory. And the reason we do that is because your memory doesn't want to be too perfect. What if the saber-toothed tiger that almost killed me yesterday had a black tail, but most saber-toothed tigers have tan tails? And so the next day I was walking along and I saw a saber-toothed tiger with a tan tail, and I said, oh, that's definitely not the one that killed me yesterday. I might walk into danger again. So it's actually good, in a sense, that we don't really have this perfect memory. And in fact, when I see the new saber-toothed tiger that looks similar to the one I saw last time, my memory will be of the stuff that I'm seeing now. Instead of saying, wait a minute, that last saber-toothed tiger had a black tail, I'm liable to say, yep, I remember that saber-toothed tiger I saw last time also had a tan tail. So we actually change our memories based upon the newest information. And this allows us, if you think about it, to keep the most novel and most flexible objects that we fear and that we need up to date so that we don't get caught up by old memories. Now, this is great in the wild, this is great for an animal, this is great for evolution, but this is really bad in a court of law or in a 21st century world where people care about the exact details, what exactly happened. And so there have been research, the most notable of which is talked about in your textbook, Elizabeth Loftus, suggesting that people's memories can be changed, people's memory, in fact, are not objective pictures and unchanging pictures of the truth. And your book's going to talk about 4 different sort of patterns of memory disruption that you're going to see in people. Now, what I find is that when people, and I don't know, it might be different from your generation. What I've noticed in my generation is a lot of us started out very liberal. And I'm using that word politically speaking, but more socially speaking. You know, it was live and let live. Hey, if you want to drink alcohol, if you want to have sex, if you want to not get married, if you want to do whatever you want. A lot of my friends were very, very liberal in their attitudes as 16-year-old high school students. And then I've gone back to my high school reunions, and what I've noticed is that a lot of my friends have now changed their attitudes and become much more conservative in life. Now that their lives have followed a set pattern, it's worked out, they seem to have these more, if you will, conservative viewpoints that things were good back then and they shouldn't change. And they actually become, I would say, in a sense, socially and politically more conservative, right? And so what happens if you ask these people to think back to their earlier days? A lot of my friends are not going to remember the liberal things that they did and the crazy things that they did. And they're in fact going to change their memories to be of them having done things that are more consistent with their recent political and social beliefs. Does that make sense? This is what's known as memory bias. And what happens is as people's attitudes change, their memories will often change in a way that mimics their change in attitude. This memory bias. So the tendency to change memories to fit with current beliefs or attitudes. Now, another way in which people demonstrate memory problems is they will actually remember something that never happened to them. Now, I want you to think about this. It's kind of a weird thought to think about, okay? But just like when I remember in chapter 5 we talked about, or chapter 3 and chapter 5 we talked about vision as a conscious process, and I suggested to you that in a sense you don't really see me. Instead, your mind is hallucinating an image of me based on the feedback that your occipital lobe gave it. And if you remember, we talked about Ben Underwood, the guy who sees with his ears. So in a sense, he creates a visual image using acoustic feedback. And so what I tried to get you to understand from those two things is that the image that you have of in me is sort of your estimation of what I should look like. And that's why visual illusions work, because they sometimes trick us into making guesses that are not correct. And so your visual experience of me is in a sense a hallucination. Well, your memories, in a sense, are the same thing. Your memory for your 4th grade party is just an abstract object in your head. And the fact that you were actually there is just one part of the memory. There's nothing special about you having been there. And so what happens is sometimes you can trick people, you can plant a memory in their head, and you can make them think that they were actually there, if you will. So Elizabeth Loftus did this really crazy experiment where basically she went to people, she invited people to be in her memory study, and she talked to their family and found out a couple of really really interesting, or not interesting, but memorable things that happened in these kids' early lives. So she would go back and find out that when I was 5, I played in a trumpet contest. My parents gave me a trumpet, and I actually played a song for people at a concert when I was 5. And so Elizabeth Loftus would find that out, and then she would find out that I hit a home run in t-ball when I was in 7th grade, and when I was 7 years old, and that was a big deal to me too. And so she would find out a couple of those things, and she would find them out from my family without talking to me. And then she'd bring me into her study, and she'd say, "Hey, do you remember, Chris, back when you were 7, you played in t-ball for Shookstown C team, and you hit a home run and ran around the bases, and you were so proud?" And that really happened. I said, "Yeah, I remember that." She said, "Oh, what about when you were 5 years old and you played in a trumpet? You played the trumpet in a concert." And I'm like, "Yeah, I remember that too." And she would then follow those two true things up with a false memory. "Hey, do you remember that time when you were 3 years old and you got lost and an old man found you and stayed with you till your family came?" And what she finds is that about half the time, after she's shown people these two true memories, she can actually get them to remember something that didn't happen to them. Okay, so she can actually have somebody engage in what she called source misattribution. Now, one of the common ways I see this is a lot of students will tell me when I talk about there's sort of what we would call an infantile amnesia that we all have. Most of us do not remember anything before about the age of 4 or 5. Your brain matter just doesn't have the ability to keep a long-term episodic memory. And I'll always have a student that says, well, you know what? I remember when I was 2 years old, this happens. And what typically happens is the person doesn't actually remember the event, but every year at a birthday party, the parents will tell that event and tell that event. So in a sense, they will say they actually remember the event when what they really remember is being told about the event later on in life. And that's called source misattribution. Now, looking at this picture underneath me is another famous experiment that Dr. Loftus did, suggesting that you can actually you can change a person's memory for an event based on how you ask about the event. So she brought people into the laboratory and made them watch a video right here of 2 cars getting into a small fender bender. You know what I mean? Where some bumpers are busted, but nobody gets hurt, right? And so if you'll see, there's a stop sign right here. And what she does is she has people watch this car wreck and she sends them home and then brings them back 3 days later and asks some questions about the car accident. And what she finds is she can change people's details for the memory based upon how she asked the questions. So she asked questions like, did you see broken glass? But she'll ask it 3 ways. She said, did you see the broken glass when the cars bumped into one another? Or she asked another group of people, did you see broken glass when the cars collided with one another? And she asked a third group, did you see broken glass when the cars smashed into one another? And what she found is people were more likely to say that they saw broken glass when she asked them if they saw glass when the cars smashed into one another. The only difference in the estimates is because of the word she chose, smashed versus collided. And what that suggests is the word you use to access the memory that you use to pull the memory into the short-term consciousness actually adjusts the memory. And Elizabeth Loftus found that she could actually have people remember seeing Bugs Bunny at Disney World if she put Bugs Bunny on the header at the top of the picture. So she would send people a survey about their experience at Disney World. Now, if you don't know, Bugs Bunny is not a Disney character. You will never see Bugs Bunny at Disney World. But what she did was she sent people a survey, and she had the header with all the Disney characters. And in half of the letters, she would stick Bugs Bunny in there. And then she would ask people in the survey if they remember seeing Bugs Bunny. And it turns out that she was able to plant false memories in people's heads based on sticking Bugs Bunny at the top of the survey. People who saw the survey with Bugs Bunny were much more likely to say that they had seen Bugs Bunny at Disney World. And so, in a sense, what all of these things demonstrate is that your memory is not an objective JPEG faithfully recopied. Now, I say that with a caveat. If you're trying to learn something for your biology class and you are forced to learn it perfectly, okay, there are strategies and methods for learning it. But the reason most people say it's really hard is because they're having to learn it perfectly. You can learn a certain set of things perfectly if you use the memory strategies that I've suggested. But as a general rule, most of the things that happen to you every day that you remember are reconstructions rather than recordings. Your memories will change to fit your current attitudes, which is memory bias. Okay, sometimes you will remember memories that people describe for you, even if you do remember being there. If you hear me describe incorrectly that somebody was wearing a red jumpsuit, you might put that in your memory. And depending upon how people ask you about the question, was your party fun or was your party raging? fun and raging are two different words. And so you can actually pull you can change people's memories based on how you ask them. And then sometimes you can just cause people to remember things that just didn't happen if you create the right setting around them. And good lawyers, great lawyers, know how to use these kinds of techniques to cause people to bring out the right parts and accentuate the correct parts of the memories that help that lawyer's case. All right, so that actually is all I wanted to talk about today. We're a few minutes early. Did you understand this idea of the modular nature of memory, that it's in multiple places? I wanted you to understand that. I wanted you to understand how you can use this distributed nature of memory in the different parts of your memory in order to supercharge your ability to learn and do well in school. Okay. And then I want you to understand that as a general rule, people's episodic memories, their memories for events that occurred to them, are typically not as reliable as we would think and are governed by very predictable patterns of problems. If you understood what I said, why don't you go ahead and type in the chat bar and let me know your understanding. How was my sound today? Was my sound too loud? Was it too sharp? I'm looking at my audio input capture, and it looks like my numbers are maybe a bit too high. I want to make sure my sound was acceptable. Okay. All right. Cool. Well, thank you very much. I understood. Your sound is fine to me. Okay, great. Cool. All right, Janiyah. Let's see. This is week 7. Remember, the second exam is coming up next weekend, so you need to start thinking about that and doing whatever studying you can do. If you were to spend 15 or 20 minutes a day for the next week studying for this exam, 20 minutes a day, that would be an hour. Let's see, 20 minutes a day, that would be almost 2.5 hours, 20 minutes by next week. So if you just start studying a little bit every day, 20 minutes, go over what we talked about in class, you'll be surprised, and use my memory cues, you'll be surprised at how much you remember on this exam. Okay. Hey, folks, you take care. It was good to see you. Have a great day, and I look forward to seeing you next week. Take care.